9FE, extracting metals. Now let's start again with some vocab that we're going to need to know for this section. So we remember that an oxidation reaction is a reaction where a substance gains oxygen, and we use oxidizing agents to provide that oxygen. If something removes the oxygen from a substance, that is called a reducing agent. So we have an oxidizing agent and a reducing agent that removes the oxygen. And if something has its oxygen removed, we say that it has been reduced. So that's going to come in handy in a minute. So in this chapter, they're describing how two different metals are extracted from their ores being the material in which we find the metal. So we need to get that metal out of that rock. First, let's get iron out of its rock. Iron's ore is hematite, and we find iron in this ore in the form of iron oxide. But we want that iron alone. We don't want it as iron oxide. So we need to get rid of the oxygen part of that iron oxide. So we need to reduce that iron oxide. And how do we do that? We throw carbon at it. Carbon is more reactive than iron, so it will displace that oxygen, steal the oxygen, and become carbon dioxide. So we end up with iron and carbon dioxide instead. And because the carbon is more reactive than iron, and it has stolen something from it, that is a displacement reaction, which we just learned about in the previous topic. A bonus point to remember is that we throw limestone in there too, because that does a really good job of removing any impurities that are in the mix. Okay, we've removed iron from its rock, from its ore. Now we want to get aluminium out of its ore as well. Aluminium's ore is called bauxite, and we find aluminium in this in the form of aluminium oxide. Unfortunately, we can't use a displacement reaction this time because carbon is not reactive enough to steal that oxygen away from aluminium. So we need to reduce this aluminium oxide in a different way. So we're going to have to use electrolysis. New keyword added to your list. How this works is, step one, we have to melt the metal compound that we want to break apart. So we have to melt down aluminium oxide in this case. Then we pass electricity through this molten metal compound, and this helps to split it up into its different pieces, aluminium and oxygen. So we have aluminium by itself now, which is what we wanted. Some downsides of electrolysis are that it can be quite expensive and can need quite a high amount of electricity to work. So we only use it when we absolutely have to, for example, when carbon won't do the job for us. The very last page for 9FE is kind of more of a discussion point and is designed to get you thinking about your opinion, specifically on whether explosives should be banned. It talks about the Swedish chemist Alfred Nobel and how he worked hard to stabilize explosives so they wouldn't explode unexpectedly, as he'd had a bad time when one did and killed his brother in the process. He therefore invented dynamite, which is a more stable kind of explosive. We need a detonator with dynamite to start the reaction. And in the end, he left the majority of the money that he'd made to form the Nobel Prizes, which you've probably heard of. So we use dynamite today in things like mining and quarrying. So it's just down to you to decide for yourself whether you think that it was a worthwhile invention and you think it's worth it for the mining capabilities, or whether you think it might have more cons than pros. And that's it for 9FE. Now you have to revise your Key Stage 3 chemistry. Good luck.